Okay, so let's dive into stuff. Um, practice, 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 quiz. Sorry, my brain was booting for a minute. There we go. So going into Chrome, I think this is about as good as we can get. So I asked several questions on here, and let me encourage you to turn to your neighbor and do the same. Practice discussing, and then we'll talk through it. When are we speeding up? Oh, let's have labels. A, B, C, D, F. No, I don't think for this one. You already sort of answered it, you know. Speeding up, slowing down, at rest. First set, and then second set of things were moving in the positive direction. I think these were the four questions I asked, if I recall correctly. Turn to your neighbor and discuss not just what, but why. In other words, tell them why. At rest. I'll change the words to be the same. Ah, there we go. It's the value. Let me make it fatter so that I can, there, which is, That's very short. What are they blahage? That's my question. Oh, hammer shark. Da, 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 da. It's hammer shark. It is. That's true. Yep. No, I don't think so. Let's discuss with your neighbor real fast. And then in a minute, we'll go over them. But make sure when you're talking to your neighbor, not just saying, I think the answers are, but you're saying, why is the answer this, that, yeah. Well, oh, excuse me. My exams leave lots of space between. So usually you won't need scrap paper. You can bring it, but usually there are plenty of margins and spaces between the questions to write. No, don't put them in yet. Don't put them in the Jujal form. Who wants another minute? Who wants another minute? All right, then let's bring it together and discuss. Can someone tell me why C is the only speedy uppie? It's the only interval where the velocity is going away from the origin. That's right. Stopped, slew, fast. This is the only thing that's going from stopped to moving. Good. Slowing down. Can someone tell me why BE slow down? Exactly. We approach the horizontal axis. We are approaching where velocity is zero. Why is F and D and F at rest? At rest is only F. Oh, that was a test and you passed. You passed with flying colors. F is the only interval you're at rest. Why? On the x-axis. What I was thinking of is 5, but no, moving in the positive direction. How do you see motion in the positive direction versus negative direction on the velocity graph? What is true about velocity when you're moving in the positive direction? When you're moving rightward, sure. And on a graph, how do you see left, right? When it's in the positive quadrant. The first quadrant. 1, 2, 3, 4. You are moving leftward or downward in the negative direction when the velocity values are below zero. CDE would be moving in the negative direction. That's true. That acceleration is positive, but the object is moving backwards or leftward while slowing down. Remember, the graph is not the object. The graph is showing property of the motion of the object. As time progresses, the value of position, the velocity is getting less negative. That is a positive the numbers are increasing. We are adding two negative numbers. They're getting closer to zero. So we are slowing down. We're still moving backwards though. Okay, so we're moving in the positive direction, A and B. When is the velocity constant? ADF, yeah, yeah. It is, velocity is constant if it is not changing. If the velocity values or the velocity graph is horizontal. A lot of people missed F.
It's because the question about at rest tripped me up on the quiz because I had ADF at first, but then when it was like F is the one at rest, I was like, well then it can't be constant at rest. But
It can't. At rest and constant describe different things. You could be at rest and non-constant if you're about to be moving, like a turnaround. Here, I'm at rest now, but I did not keep a constant velocity. Here's a constant velocity that is not at rest. Here's an at rest, which is also constant. Different quantities. They describe different parts of the motion. And something is constant, something's velocity is constant if the velocity is not changing. Follow-up questions on this, on the interpreting v-graphs. When is acceleration negative? Acceleration is negative BC. When is the slope downward? B and C. Acceleration is negative when the slope of velocity is negative. Slope of velocity is acceleration. That's how I defined it. What's the slope of the position graph tell you? And the slope of the velocity graph tells you acceleration. Good. How do you see displacement on a velocity graph? Do you remember that? Area under the curve, yeah. The line, the graph. Okay, follow-up questions on this. Feel confident with this. We spent a lot of time. There will be 4 probably questions on midterm about interpreting velocity graphs. We spent, well, maybe not 4, 3 questions on the midterm about interpreting velocity graphs. We spent that much time on them. It's worth the time. What about acceleration graphs? Probably none. Position graphs, probably 2 questions, just because they're so easy, right? Does anyone want to review position graphs? I felt like last week you were kicking butt on them. Want to ask a question? Sure, let's do a velocity into position. Let's do it. Turn to your neighbor and discuss for 2 seconds. Not 2 seconds, several seconds. It's going to take me a little while to draw this. Again, the task, turn that velocity graph into a position graph. Who wants another minute? Okay. All right, here's what I see when I look at this. I see something that I'm not going to give you. When I have you turn velocity into position or acceleration into velocity, I'll give you piecewise constant. Because we're going to see the B, C, and E are parabolas. And doing really the mathematics of parabolas and understanding just how the slope changes, that's calculus level. So this is an algebra-based course. I'm not going to have you turn this in. I might ask you which of these graphs corresponds qualitatively then. Yes, that's reasonable for me to ask. What is the total y, what is the total vertical coordinate in the displacement? That I could ask. But having you sketch this in full, you'll notice on the homeworks, I've never asked you to draw the complete graph when you've got a varying, smoothly varying velocities. That said, let's tackle this qualitatively. I haven't put numbers on the axes even, so I don't feel bad about doing this now. The next first thing to say, the second thing to say is that velocity can't tell you position exactly. Velocity can tell you the change in position. So just to be a dick about it, I'm going to assume the position starts here. You could start anywhere along the vertical axis and be correct as long as the subsequent values match up. Okay, I want this better. I see a largish, steady velocity. Therefore, I see a larger steady slope in position. I see that B is slowing, so I'm going to draw a tapering slope. This is motion which is moving initially at the same speed, but then the speed tapers off until I'm at instantaneous between B and C intervals. My slope is horizontal. Now C is symmetric to D. C is symmetric to B. That is ugly. That is not parabola. So I am speeding up in the negative direction. First going slowly in the negative direction, then fastly in the negative direction. Now D is moving steadily negative. Looks like about the same speed as A was, just in the opposite direction for a shorter interval. E tapers off. And finally F at rest. Here's my position graph. Ugh, those look more like circles. They should be parabolas. Did you draw something like this? What could I also ask you to do? I could ask you to find the total change in X. How would you do that? How would you find the change from here to here, the displacement? Area under the velocity graph. Here is the displacement that would just correspond to the delta X here. Gesundheit. Yeah? Is good? Follow-up questions on X graphs. Nope, because this could start anywhere. Maybe the entire position is negative. You can't tell starting position just based on velocity information. Homework questions? Homework time. Yeah, no, last question about this. Yes, last one on the quiz. What did we just learn about free fall? Doesn't matter whether you're heavy or light, and it also doesn't matter if you're moving up or down, as long as you're not touching, as long as you are not touching things, your acceleration is equal. Yeah. So two relatively heavy balls, no drag. Drag is ignorable. There are only like two examples that I would use in this class that we will ever talk about drag. Parachutes, and no, that's it. We'll only ever talk about drag in the context of parachutes. It's the only place that it's going to be important for us. Yeah. What's the slope? Has the slope changed? Showed the experimental data from the thrown ball, I think, last week. This is what it looks like. Rising and slowing. Peak. Falling and speeding. Slope is here, negative 9.8, everywhere. It doesn't tilt, it doesn't joint. Sure? Does that help? So again, one of the big laws that Galileo discovered even before Newton was, I think the most simple way to state it is, unless you're a parachute or a coffee filter, unless you're touching something like a hand or a rocket engine or a table, then you must always accelerate, always accelerate at 9.8 meters per second squared downward, which doesn't mean speed up, remember, as we just discussed, doesn't mean speed up. Slow down, changing your velocity at 9.8 meters per second, slowing squared, or speed up going when you're moving downward at 9.8 meters per second squared going downward. Homework problems. Another thing that I've seen multiple times asked is, it gets back to, I think that many people are having trouble with slope. Whoa, that very horizontal axis was very not horizontal. That's not mindful, that's not demure. Find me the acceleration. Search your neighbor and discuss. You know what? Put this in the usual form. Your name is A. Find me the acceleration for B. Doesn't have to be exact. I'm looking for, I have hand to sketch this anyway. Where is A? What is A? I mean, my tick marks aren't all exact. Yeah, put this in B. Give me your name, not like a fey lord. I'm not going to steal your name and you'll be nameless and alone. Or maybe I am. Maybe I'm a fey creature. A phasic creature. Oh, and yeah, these are time in seconds. And velocity in meters per second. No, let's just be silly. Why don't we have these in time in milliseconds? That was a problem that people struggled with, doing unit conversions there. If you're not sure what acceleration is, please turn to your classmate and ask. Someone asking, defining what acceleration is, you need to, it is something you should know. Okay, 2 more minutes. 2 minutos más. Hmm? I'm not contagious, by the way, doctor said. I mean a medical doctor, not this doctor.
was prepared because every time I go, I'm like, David, what's wrong with me? You're a doctor. He's like, I know that. I asked him if he knew how to wrap a knee, and he told me no. He told me no, that he did not know. He's lying.
Technically,
In an ambulance. He worked in
I've been in an ambulance. That's not why I'm a doctor. Wasn't driving it. Alrighty. Correct answer is 10,000 meters per second squared. 10,000 meters per second squared. And here's how I do it. Wait. Oh. Yeah, 10,000. Okay, here's how I do this. I pick any 2 points on the line. For instance, 2, 0 and 5, 40. Right? Acceleration is the rate at which velocity changes. By definition. Yeah. A millisecond is a teensy fraction of a second. If I'm getting to move that fast in a teensy fraction of a second, think of how fast I'd be moving for a full second. Crazy pants fast. 10 meters per millisecond per second.
10 meters per second transferred over to seconds, then it'd be 1,000 meters per second.
Yeah, but acceleration isn't meters per second. Acceleration is meters per second squared. The vertical axis is meters per second. Slope would be meters per second per millisecond. No, I would encourage you to write this in SI, in meters per second squared. Okay, so acceleration is the rate of change, and let's find the slope. Slope is V2 minus V1, change in V, over T2 minus T1, change in T. My change in V goes from 40 to 0. My change in T what did I do? I just goofed on something. Where'd I goof? Okay, where I was doing it. No, it's over the distance difference in time. Where I was doing this previously when I said 10,000 was from not 2. It might not cross 2, actually. I hand sketch this. Give me a break. And I would accept anything within plus or minus 10% of 20% of what I said. So let's do 5, 40 and negative 10, 1, negative 10. What's 5 minus 1? What's 40 minus negative 10? Oh, for dog's sake. Look, and this isn't even, I can't even blame this on being sick. I can't blame this on being tired, and I am both sick and tired. I'll send that bun back to the writer's room. Well, why do I say 12,500? Because what I would actually, when I am actually doing this, what I would do is I would plug in whenever you're, as soon as you can, transform to SI, transform to meters, kilograms, and seconds. So the fact that T is in milliseconds, I should actually be writing this T as negative 0.005 minus 0.001 which is 0.004. So I amend my answer. I would prefer to say 12,500 meters per second squared. 10,000 is close enough. If you got 10,000. If you got 15,000, I'd call that good enough. Yeah.
Determining a slope, would you rather use points far away from each other?
Yeah.
2 points closer?
You get more accuracy if you do further away. Unless you see something exactly crossing lines where you can see the real value at this point is this. Yeah, always pick further away.
From milliseconds a second, shouldn't it be 0.05, not 0.
That'd be centa. That'd be centa. Divide by 1,000. Shift the decimal place 3 times. No, milla. Think of it this way. How many cents in a dollar? Centa is 1/100th. That's the original meaning of cents. Yeah, so milla is smaller than that. Yeah. Sure, if you've got, what I was just saying is if you're crossing grid lines where you see it exactly passes through this grid line or exactly passes through that grid line, that gives you an exact value. That's a better technique. But in general, pick as far away as you can. Small error in here, it's like balancing with a balancing bar if you're holding your hands here or balancing going out here. Other questions? Techniques? Yeah. I will never give you varying accelerations except for piecewise varying. Like acceleration might be this, then that, but I won't have smoothly varying accelerations. That's beyond scope of algebra based. Other questions? Anyone interested in farming? Other questions? Okay. So here's how to find an acceleration. On the homework, you had a question about finding the acceleration of a grasshopper. And a number of people missed this point. Here's to find the acceleration, find the change in y over the change in x. And please note, by the way, the change in x is not always just 5 here. It's 5 minus 1. It's the final value, horizontal value minus the initial horizontal value. That does not necessarily start at, it does not initially start at, that does not always start at the left side of the graph. Wait, I want to go back here. Part 2 of this question was find the displacement. Find the displacement. What's the total displacement in this time interval from 1 to 5? How far do you go? Turn to your neighbor and discuss and put your best shot in E. I'm sorry, in the next question. Is that C?
Correct. I thought you meant
I said something and you're like, what's this feeling? Oh, the fact that you do everything you do. This is jealous.
What do you mean finding the straight down? You have two triangles. Area underneath the graph is not this region. It's this region and this region. I will sketch the area for you. That is the area bounded by the graph. It is the graph to the horizontal axis, not just the graph to the lowest point of the graph. JK. Oh, nobody's got it right. In a single person. That cooking is a good thing. What's cooking mean?
Being cooked is bad.
Well, I suppose that makes sense.
But like, we.
Yeah, what's that?
We could, like, we're burned.
Yeah, no, that makes sense. But what did I hear just the other day? We ate, that's totally eaten. What's one of those new slangs? The new lingo.
When did we decide that, like, I would care more if I would be more if it was his girlfriend? But it's not.
Alrighty, you want my 5? I shall give you what I would write on my equation sheet if I were in 111. I mean, actually, I am in 111. If I were on the opposite side of the podium. First off, a note, a notation note, a note about notation. If someone says delta S equals foo, and another person says S equals S initial plus foo, who's right? Which form is right? They're both right. Means the same thing, right? What is delta S? Delta S is, and if delta S is equal to foo, then we could just add SI, initial S, to both sides and get S equals SI plus foo. I'm just making things up. This is an equation. This applies to any equation. Yeah. So for instance, some sources that you see online will write X equals X initial plus V average T. Yeah. That's one way of writing it. What I would say is throw that Xi to the other side, divide by delta T, is the definition of velocity. Both ways are equivalent. You can write either way. Yeah. You see that those are the same equation, just rewritten? So this is some core, it's a core piece of physics thou shalt know. Thou musteth know. I should put double-headed arrows because they're really equivalent. And I will never give you A's that vary smoothly. So you can always just take A equals A average. Okay, so those are the two that I say aren't really equations, they're more sort of the definition of V and A. But still, if you're not sure of them, these are things to know, or if you don't know them, put your own equation sheet. Put them on your equation sheet. Next are two equations for displacement. If you've got acceleration in time and initial velocity. And again, I want to emphasize, but seriously though, what is V average? V initial plus V final over 2 is an average. Are these really different equations? No, not really. If you're fluent in algebra, you can convert between these different forms. But I'm going to write them as separate equations because it may be useful to you. And finally, if I were a rich man, no, if I had only space for 4 of these lines in my brain, these are personally things. If you know these, you really know these, you can convert any of these to any others, any 2 of these into the rest. These are the 4 things that I keep stuck in my skull. But as you see on the homework, maybe one equation is more useful, maybe the other equation is more useful. Is there a bird in here? I keep hearing bird whistles from over there. Maybe it's something in the building. ASU is #1 in innovation, making things sound like birds. Whatever. Whatever. Okay, we did not do very much problem solving. Monday will be entirely dedicated to practicing late problem solving. We're about out of time. Any questions before we get out of here? You are all awesome people. I love each and every one of you. Get out of here. Discord. Thank you, Marcos. And I'm going to send out an invite on Discord, an invite to Discord on Canvas. 2 seconds. Oh, Chem, yuck. Hold on a second. Let me send this out before I forget a 10th time.
We're not doing calculus, all of our velocities, we calculate the velocity average.